Okay. How are you, Christian?
Oh, great. Yeah, it's nice to talk to you and hear from you.
No, no, nice. Nice for me. Thank you very much. Basically, Christian, and for our followers, this is a summary in regarding the video that you sent to me and the email with the information about the configuration of your electrical system, solar system, and air condition, portable air condition installation. And we are going to talk about that, and we are going to explain to our followers the pros and cons about those systems. And thank you, Christian, for being here, and thank you very much for share that wonderful experience. Before we start, I want to know how many months are you working on that, and approximated how much money is the investment at this moment?
Yes, very good question, Mr. Lopez. So basically, we worked on that, the technology that went into it and sizing it and working with e.c.r up in Fort Lauderdale. I started doing that probably in January. I met the people at e.c.r at Go in Miami. They walked me through it. The purchasing took about a couple of months to do that, and then we began the installation in the Hurricane Cove Marina and Boat Yard on the Miami River in the beginning of May, around May 1st, and it took us about 2 weeks. We had some other jobs to do, along the way, but took us about 2 weeks. I worked along with a very important ABYC certified technician. That's a critical component too, even though I have some background. I think that's always important. And as far as the cost is concerned, the different solar panels, batteries, cables, all of that cost about $15,000. And then, of course, the labor that went into it, and that's subjective to whom you're working with. So I think really, when I was looking at the cost perspective of it, the question always is, how much is too much? The boat is now over 10 years old. So the question is, how much do you put $15,000 into it? What's your return on investment? Get into that a little bit later versus the generator, which we also put in a new generator, which cost about $6,000 to do that, plus some labor. So all in all, that's how much it cost. It took a great deal of effort in checking this, working with the right companies, and most importantly, the classes that I took with you gave me, I think, a solid foundation to understand what the electrical demands were, the wiring gauges, etc., all of that, so that even with the help of the ABYC technician who did the installation, I can be certain out here when I'm cruising that I can repair things or troubleshoot things when they aren't working properly.
Oh, thank you, Christian. Okay, basically your boat is a catamaran 40 feet, no?
Yes, a 2009 lowered 40 catamaran.
Correct. Okay, and it's a couple of Yanmar 3 cylinders engines, and the boat is in great condition. Okay, and we are going to check the first slide is about the configuration that actually you have in your boat. You have a 3 group of solar panels, 3 MPPTs, and you have one here, other here, the cranking batteries, and you have 3 lithium batteries connected to the positive bus bar and negative bus bar. This is basically the diagram.
Correct, and the DC to DC.
The DC to DC charger. That's correct. Now we are going to talk about that. Okay, great. And now we are going to talk specifically about the bank of batteries. What is the capacity of the battery bank, Christian?
So the house battery is 300 amp hour rely on lithium batteries, lithium iron phosphate batteries. So a total of 100 amp hours. And yes, those are the batteries right there. And I put a lot of research into that as well. So there are a lot of battery manufacturers out there. The guts of these things are very similar, but the quality can be a huge difference. So one of the reasons why I chose that manufacturer is because it's very well known. Even they sell that brand now in West Marine. So I think rather than buying some unknown brand off, Amazon or eBay or something like that, I can't afford to have the risk of a fire out here with battery that's poor quality. So they are expensive. They do cost about close to $3,000 each. So that's the majority of the expense on the solar setup. But as with everything, I think quality is much more important than saving a dime here or there.
Okay, I remember that you work a lot trying to find the best group of batteries. Are you happy at the end of the day with those batteries?
Yeah, that's actually a good point. So all these manufacturers have different footprints of their batteries. So they might have the same amp hours, but another manufacturer that's very well known had a similar size battery, but it was too high. It wouldn't have fit into the same compartment. Another important thing to consider was the cable run. You can see those cables there. So there are high gauge cable. I think they're 4-aught cables, which is very expensive because they're copper. And the MPPT controllers are just on the other side of that bulkhead there. So I couldn't move those batteries to another location without having to increase the gauge and thereby the cost of that wiring. So I had some limited space. I wanted to go with a battery footprint that was the same as the AGMs before, which is a 4D cell. And these are exactly the same size. So, with a little bit of, moving around, you can see they're a little diagonal there. These fit perfect and effectively increased my amp hour from previously I had 600 amp hours AGM, of which you can only use 50%, so effectively like 300 amp hours, to virtually 3 times as much in the same space, because with lithium iron phosphate, you really can take these down all the way to as low as even 10%. I never do that, but that really improves our range of use.
You have a additional space in your boat to increase the bank of batteries in the future?
I technically could, but we've chosen to use that other compartment for our dive compressor. So I could choose either to enjoy diving or have air conditioning. So I guess we go with the prior.
Yeah, okay, great. At the end of the day, this is the equation, this is the summary of the configuration of the solar panels. You have 3 groups, no? Can you explain that slide, please?
Yeah, sure. So there are a few very important considerations when we put this together. The first limitation that we have on the boat is the square footage available. So we have solar arch and we have the coach top where we can mount the panels. So I had to basically go with 3 different types of panels to maximize that square footage. We had maybe, a little bit over 100 square feet to play with. I ended up with actually combined total about 90 square feet of that space, so really utilized it well. We have 2 Renogy panels, which fit perfectly into either side of the solar arch. Yeah, and I specifically purchased those because of the size. They fit perfectly. So the most wattage per square foot there. Then I have the bifacial panel, which by far is the most efficient. It's a different type of technology. It has silicon cells on both sides of the panel, so it's able to absorb reflective solar radiation and basically makes that panel very efficient. It's by far the most efficient panel I have. I wish I had more of those. But then on the on the salon top, we had to go with a flexible panel. For one reason, it's curved slightly, but more importantly, the sail boom is up there. And if I have to go up there, while sailing or something like that, I really can't be stepping around a hard panel that is at risk of shattering and cutting my feet open. So
yeah, later we are going to talk about that. Yeah, because this is very, very important, that topic. In summary, we have a three group of panels, the Rhino G panels, biphase panels, and flexible panels. The first group is two panels of 175 each one, in total 350. The second one is 450 watts. And the third group is four panels of 180 each one, in total 720. Those panels, the first one, 350 watts, generate during the day 120. The second one, 450, generate 209. And the third group, 720 watts, generate only 220. This is basically for what reason?
Well, that's actually because there are three different manufacturers, three different technologies. That's a very interesting comparison. And I was trying to figure this out over the 3 months we're out here because, at face value, it doesn't make any sense, right? We should be producing a lot more, for example, on the flexible panels.
Yeah.
So what I learned about the flexible panels is all solar panels are very susceptible to heat. So heat degrades their capacity. And when you read something like 180 watt capacity, that's in ideal conditions. And the ideal conditions are like, up in the northern climates at 32 degrees Fahrenheit, just above freezing at noontime. That's not realistic. So actually, flexible panels, because they're mounted on the cabin top, they get very hot. The other day when I measured it, they were like 135 degrees, and it's about 90 degrees outside. So, they pick up a lot of heat. I did mount those on a material that I researched online called coroplast, which is corrugated plastic, which has channels in it, so that when we're at anchor and the wind is blowing from the front of the boat, that wind will be forced through those channels and cool those panels down a little bit. Every degree makes a big difference there. The other thing that I found was the second most important thing to consider is shading. So shading from either the mast or the boom or the clouds seriously degrades the capacity, and that has to do with the wiring of the solar cells. They're wired in series, and basically if there's a solar cell that's in the middle there that has some shade on it, it's effectively producing nothing. And although there are some diodes built into those solar panels to avoid the leaching of power from one cell to another, it generally degrades the wattage to like 10% when maybe only 5% of the panel is shaded. So that confounded me. I was confused about that for days until, I researched that a little bit more. And I realized how important that shading is. And then the third interesting component to consider is the angle of the sun. So ideally, those panels would be mounted at like a 30-degree incline because of the direction of the sun, so that the sun hit it directly. I can't really do that on this boat. They would blow away in a storm or something like that. So we're basically, straight, flat, horizontal. And so obviously that degrades the wattage capacity too. So those are the three things to consider.
It's incredible, no? How the ideal is impossible to get that amount of power for different reasons, no? Is in real at the end of the day, you have you collect around 60% of the theoretical, no?
Yeah, correct. And that's very important to consider when you design your demand or your solar system, right? You have to do your demand curve, how much power am I going to need every day? And if you go out there and you think like, when I started researching this, 1,500 watts, that's tons. I never use 1,500 watts. Well, this over 2,000 watts of solar. And that effectively would mean that I need maybe a third more square footage somewhere out there, extend the solar arch, and obviously increase the cost from 15 to 20,000. So or something like that. So obviously, that cost those $5,000 to make this 100% off grid. I chose to go a different route with that, and I guess we'll go into that a little bit later, how to make up for that shortcoming.
Yeah. Oh, great, great, interesting. Okay, in this slide, we have that you generate every day 550 kilowatts per hour, and in total you have 549 from the solar panels and 330 coming from the shore power or the generator. What is the meaning of that amount, 330?
Yeah, so just a clarification. This was over the 90-day period. So actually, looked again, I've been out here, 122 days. And yeah, so basically the kilowatts that I generated in this time, the solar panels, we generated 549 kilowatt hours in those 90 days when I did this sample the first time.
Okay, I understand.
Yeah, and the shore power that I had to add to that to basically come up with the 880 kilowatt hours that I needed in the 3 months that I've been out here. To generate that either myself with the generator, or like here for the last 2 months, we've been in a marina here in Curacao. And so we plug into the shore power to make up for that. And the thought was, it's not so bad when it's hot out and humid out to run the generator a couple of hours, 3 hours a day. Also helps with keeping that generator exercised. The worst thing you can do is use your equipment. You want to run that diesel generator up the diesel, so that helps too, and it cools down. So actually, I'm very happy with the wattage that I chose, the 1500 watts, and how we are able to come up with the wattage that we need every day to run this boat.
Interesting. And let me analyze the next one. This is the consumption per day, the consumption of power per day. Basically, I want to explain to our followers that this analysis is with a portable AC unit, air conditioning unit, portable unit. It's a small unit, one a small refrigerator and other small loads. In total, the consumption is 349 amps per day, or 9.2 kilowatts per day. This is in average, no?
Yes, that's right. And
okay.
Exactly. And on average, just to kind of explain how much that is, an average U.S. household uses about 35 kilowatt hours per day. So we're only running, as you said, a little refrigerator, AC, that room air conditioner, which is only 2,300 BTUs, and some little loads here and there. Yeah.
Okay. Great. And according with that information, you mentioned me that you have a deficit. You have a deficit per day at 3 kilowatts per day, and you need 2,000 watts of solar instead of 1,500. But the inconvenience is that you don't have more space available.
Exactly. So we went out there and we would have had to rebuild the whole solar arch. The boat would have looked very strange also. I mean, there is an aesthetic to a sailboat, right? So I didn't really want, 6 feet of solar panels hanging off the back. I could have done it, but there's also windage concerns there. So I really had to stick with the square footage I had available.
Yeah. And okay, this is the real situation. Thank you for sharing that information. And this is the information that we have about the generator. The generator used around 0.3 gallons per hour at half load, and you run the generator in between 3 and 4 hours per day. With that information, if the gallon of fuel is around $6 per gallon, you spend around $10 per day using the generator. It's not bad, no?
Exactly. And that varies. Some days when we're running the water maker, for example, which is about once a week, we have a water maker that makes 16 gallons per hour. It's very efficient. It uses less than 20 amps. But I do run the generator during that entire time. So I sort of, let's say I run down the battery bank until the weekend. And then on the weekend, we go out to an anchorage where there are not some other boats around. And I use the fresh salt water there to make the water. So I'll run the generator maybe on a Saturday for like 5 hours straight or 6 hours straight to fill up one of my water tanks. So it's not that I run the generator every single day for the exact same amount of time. And that's the beautiful thing about lithium battery technology. You don't have to recharge the batteries like the lead acid all the way to 100% each time. You can let them, you can leave them alone and only charge them to 50%. That's fine. You can take them all the way down to 10%.
So this is a great point. Oh, great. That information is very important. Okay, good. Okay, great. Oh, nice. And this is the amount of cables that you pass in between the solar panels and the MPPTs. What gauge of wire you use?
So that's actually very interesting. So the two outside panels, those are those Renogy 175 watt panels. They're actually wired in series. And so because of that, we are able to utilize 10 gauge wire instead of having to increase the gauge of that wire to, I don't know, I'd have to look at the ABYC table, but maybe 4 gauge or something like that. So we're able to go with a thinner gauge wire because those two panels are mounted in series. Now, the bifacial is one panel, so that's just directly to the battery. It's not mounted, it's not connected to any of the other panels. It has its own MPPT, and that's why you see there are 3 MPPTs there, one for each array. Another side that it's not advisable to combine different manufacturers and different solar panels into a series bank, or into the same MPPT. So I've been advised that I need to keep those separately. They're separate demands, separate production capacities of these panels. So that's why they're wired that way. And although that cable run looks very thick, it's actually just 2 sets of cables, one series set from the Renogy panels and the 10 gauge wire run from the bifacial. But because of UV degradation of the cables, I chose to put those like in a neoprene jacket, and basically that's why it looks so thick, because I don't want to have any sun destroy the cable out there. That looks thicker than it really is.
That's correct. But you install the cables very well. Good protection, and this is good. Probably you have cables for a long period of time. This is great. And what about the DC to DC converter?
Oh yeah, if I could go back and redesign this, there's one thing that I guess I didn't do right. So this has to do with this DC to DC. So as you can see, there's 2 different technologies of batteries. There's the starter battery, which is the one on here, is for the generator. And I felt it's very important that lead acid battery, it always is charged, because if I don't run the generator for a week, who knows, all of a sudden the battery's dead and I can't start it, and then I'm in a world of trouble out here. So I felt it was important to be able to charge that battery directly. Now, because the lithium ion batteries charge at a different voltage level than lead acid, and Mr. Lopez, you'll remind me what that is, which one's higher. I don't remember which one. But I need that DC to DC charger so that it can take the voltage from the lithium ion, and which is higher, I believe. I think it's like 14.7, and reduce to, I think it's 13.7 or 14.2. It's a small amount, but reduce it to that same maximum voltage level to charge the starting battery for the generator. So that's all that does. And the mistake that I made, one of the opportunities I had was to actually use the alternator from the diesel
Yeah.
engines and
Mhm.
Mars to also charge the house banks, which they produce about 70 amps. So that
In this moment, you have a lead acid batteries for the engines and a small group of lead acid batteries for the house.
no, I have just lead acid spiral cells for the starting batteries for the two diesel engines, and that's because they're cranking batteries. You can't
Uh-huh.
use technology because they don't have the cold cranking amps to start an engine. That's what I was told. So you
Yeah.
can't have, you have to really, technically, you do have to have two different uh, types of batteries. One for the starting, which are lead acid because of the CCA, and the other for the house. And all the house I have is lithium. I really don't have any other. The lead acid batteries that AGMs that were in before were already 6 years old. And that's another thing. Lead acid has a much shorter lifespan. If I were out here every single day, like I am now, they last generally like 3 years, whereas the lithium lasts about 10 years.
Okay. What is the capacity of the alternators on the engines?
So they're 80 amp alternators. And, previously when they were hooked up to the AGMs, they would very quickly recharge those. If I had them both running, uh, there was a maximum allowance of 100 amps that I could feed into the batteries. So I could quickly recharge those house batteries previously. And that's what the previous owner would do. He would basically recharge the AGMs by running his engines every day or the generator.
Okay, great. I don't included the information about the windmills. How much is the production of power of the windmills?
Yeah. The wind generators are, I'm not sure whether they're really worth it. They're called Amp-Air 100, and it's because they're supposed to theoretically produce 100 amp hours per day of power. They don't really do that. Right now, there's maybe a 10 or 15 knot wind gust, wind blowing out there, and each one's producing about 2 amps. So on a good day, maybe we're producing 48 on two wind generators, not 200. So not anywhere close. And you really, I don't know, I don't want to be at an Anchorage during,
Mm,
30 gusts. So yeah, it's possible. But the other thing to consider, you can see in the picture there, there's shading from these things. I talked about shading, how it degrades the panel capacity. So
yeah.
when the sun is a certain direction, that windmill is going to cast a shadow to that solar panel, and every amp that it produces is going to be offset by the shading. So I'm actually thinking of getting a skill saw and cutting those things off.
This is a great conversation, Christian, because you are living in the boat with your wife. In this moment, you are in Curacao, no?
Yes, correct. Uh-huh.
Yeah, and this information, guys, is a real information because those are the numbers that Christian have every day in consumption. Great. And basically, you start the generator to run the domestic unit for a couple of hours, and after that, you continue with the portable unit.
Yeah, that's right. So, we do like to sit here after dinner and cool down and watch some YouTube channels. That's what we do here, your channel included. So we like to, keep on top of things. And when we're doing that, we'll run the generator, and that has that basically those three different points to doing that. One is, first and foremost, cool down the internal temperature and get rid of the humidity. The second is charge up the house batteries, whatever might be missing, to get it to at least 85% charge level.
That's correct.
The third reason is, just to exercise the generator, to make sure it doesn't sit there. I had a problem like that with the brand new generator after 150 hours. I didn't use it for 4 months, and then I had to flash the unit to be able to re-energize it because I didn't use it. So one of the worst things you can do is not use your equipment. So that helps with that.
Oh, that's great. Great. And in this slide, I have the analysis of the app that you have in your cell phone. Can you explain a little about that?
Yeah. So it's a very good app that I have on that comes with the MPPTs. So the MPPTs and are manufactured by a company called Victron. And they have an where it's Bluetooth, it's available on your iPad, on your iPhone. And so I'm able to really monitor all these, the production levels. I can see if there's a problem. For me, this is just very interesting to kind of do the math. Little science experiment every single day. Oh, where's the angle? Is it cloudy today? Are we going to that 85%? And this software that they have available is ideal for that. It gives, basically a month snapshot on consumption patterns, on production patterns from the different types of solar panels. So it's extremely useful for monitoring your setup. And also, if there's some sort of a problem, like the other day, I had a problem with my MPPT. I don't know why. I downloaded a new software version, and then one of the MPPTs didn't work. So with this, I saw, it was offline. Why was it offline? I don't know. But if I didn't have that software, I may have never stumbled on that, and then I would be scratching my head why I'm not, being able to recharge my batteries. So the software is ideal for it.
In this example, that measurement was at noon, and it's a 67% of the charge, no?
Yeah, exactly. So, as I said, depending on what I charged the battery level to the night before, if it's 85% or 100%, that's obviously going to dictate what level we start off in the morning. So routinely, we're at around, I try and target like no less than 50%. I know that's an old lead acid concept, but in the back of my head, I'm trying to not bring the batteries below the 50%. So as you can see here, by about around, this is actually, it says 9:41 in the morning. So that must have been a day where I charged it pretty well the night before. But I still had to make up another 20% or, about 200 amp hours of capacity.
Yeah, in this particular case, the air condition is running at low speed. The consumption is 23 amps and is 308 watts. But later you take another measurement, is this one, and the consumption in amps increased to 50 amps. This is because you increase the speed of the air conditioned unit, no?
Oh no, I'm sorry. This is the other way around. Actually, this is production. So it's a positive. So you can see.
Yeah. Okay.
At 9:42, we were adding 8.6 amps to the battery. That includes whatever we're running at that time, which is really just the refrigerator and freezer, which is maybe 15 amps. But then you can see like less than an hour later, half an hour later, the sun goes up a few degrees, and boom, we're up to basically producing, close to 50 amps. So what's interesting to see in that example is how quickly the angle of the sun has an impact on what the solar panels are able to.
Yeah, that's true. That's true.
5 times as much power.
In that case, this is probably the best scenario, no? 69%.
Yeah, no, it's very good on that day. At imagine it's 10 o'clock in the morning and we're already, at 70% charge there. We only have, you can see, 209 amp hours to make up. So I think on that day, we did quite well without even generator or shore power because the sun was ideal that day, blue sky.
Oh, great. Oh, thank you. This information is valuable for me. And this is when you start the air conditioning unit, and this is the temperature of on the grill, 70 degrees Fahrenheit, no?
Yes,
and,
exactly.
And in the other case, is 69, and this is the temperature of the sensors.
Yes, exactly. So the indoor sensor on the first, this is in low mode. So there's a difference ambient versus output of 10 degrees. And in that mode, the unit only uses something like 180 watts of power. So if you remember those old incandescent light bulbs, it's like less than 2 light bulbs worth of energy if you think about it. So that's, I think, pretty dramatic that we're able to produce that much cool air from that little unit.
Yeah, that's correct. In other words, to summarize that information, Christian, that the configuration that actually you have in your boat is of solar panels, a battery bank, and the MPPTs and the DC to DC charger is designed to work with that air conditioning unit, that small portable air conditioning unit, the refrigerator, and a couple of outlets working at the same time. That configuration is good to supply power for those units for one day, no?
That's right. Actually, a big continuous draw on the battery panel is the charger inverter that we have. So that uses about 28 watts. It doesn't sound like a lot, but it obviously adds up over the course of 24 hours. So one thing we do when we're not on board or not using anything, we put that inverter into what's called surge mode, and that decreases the wattage demand from 28 watts to only 8 watts. So funny thing about living this lifestyle from an electrical perspective is every watt really counts, and your brain starts to, I guess, think differently, like how sunny is it? How can I save some money here? So efficiency is part of the formula too. Changing all the light bulbs to LED bulbs. These little lights that we have in here, each one uses less than 1 amp. Then we have these fans that move in our bedroom. They use less than 1 amp. So our consumption is, as you saw before, very low. It's like 20% of an average household. And a lot of that has to do with the efficiency models that we had to put into place here.
I have a question, Christian. When you are in the middle of the ocean, in the morning, 6 a.m., 7 a.m. in the morning, you start the generator to recharge the battery bank. What is the procedure?
Yeah, so that's actually the longest passage we had was from Dominican Republic down to Curacao, which was about 4 days. And one of the concerns I had was I can't really run the generator if there's a heavy sea. So we had like 5, 6 foot seas out there. It was very choppy. And I don't want to let air into the intake of the generator for the cooling water. That's really a bad scenario. So the lithium batteries, what's good about them is, you can run them down to 10%. So because we weren't running the AC, we really only had the freezer on. And then obviously the Raymarine, all the multifunction display, the radar, all those have a drain on the battery too. But we never got really below 50%. Also, the wind generators, when we're out there on the ocean, they do help out a great deal. They made a lot of energy for us. They were routinely running at 4 amps each, so about 8 amps an hour that we're adding to that. So the design, even though it was actually quite perfect, I'd love to add a hydro generator to the setup, but that's a whole nother cost element. Hydro generator is like a wind generator, only you stick it in the water.
Yeah. Okay. All right. In the morning, you start the generator a little, and you recover the charge of the batteries. That's an important information. Oh, great, Christian. I am too happy with this conversation because I think that this information is useful for other people interested to convert the boat into a hybrid boat or fully electric boat. In my opinion, your boat in this moment is a perfect example of a hybrid boat.
Yes, and I think that's really the best way to go about it. The other thing that I think when I was on one of these forums in the past, I had like this great idea, this all electric, and then somebody said to me, well, if you create this basically science project on the water, the problem you're going to have is with maintenance and repairs, because you might not be able to get the parts, et cetera, et cetera. So sticking with proven technologies like a diesel engine, maintaining that, overhauling it when it needs to be maintained, and then combining the proven, historically reliable technologies with, some cutting edge, but well-proven technologies in the solar market is really, I think, the ideal way to go about if you're in this cruising world where there's no access to, repair and spare parts easily available.
That's true. It's important keep in mind and explain to our followers that the theoretical calculations are in the real life separated from the real situation. No, it's the equation is so far.
Yeah, I mean, they start off always when they tell you, oh, do a consumption pattern, right? Sit down with an Excel spreadsheet and how much, does your coffee maker use and your hair dryer. And, it's like actually kind of funny. I don't know who uses a hair dryer. But I mean, they really get into technical details. So you can do that all theoretically. But really, I found after, 3-4 months of this, reality is very much different from theory because of shading, because of cloud coverage, because of, there's a lot of dirt in the air that lands on our solar panels and stuff like that.
Yeah, that's true. Huh? Incredible. Great information. Great information. I love your help to explain to our followers how important is the selection of the batteries. The selection of the batteries is critical, no? Especially during the creation of the battery bank. And also the size of the battery bank should be according with the capacity of the solar panels. How was your experience in that calculation? I suppose that e.c.r and Victron, they help a lot to you.
Oh, absolutely. I can't, you can try and do this on your own. You can, and absolutely, there's no problem with that. But I think, a company or technicians that have the right training, that's invaluable. Because if you don't size up the wire gauge properly, if you don't do your terminal crimping properly, if you don't size up the battery bank with the right MPPTs and the right switches, don't do that right, you could have a situation where a lithium battery basically has a chain reaction, a runaway, and you'll burn your boat down. So that's really, I think, important when you get into the design of things and the choice of hardware and installation. When designing that system, like I said, I had basically only so much square footage, both as far as where I could put the batteries and the solar cells. So I had to work with that. Ideally, we would have had 2,000, maybe even 2,400 watts. But I think with the 1,520 watts, where we produce maybe 2/3 of that in the real world environment, or maybe about 1,000, close to 1,000 watts out there per hour, I think that's reasonable. And for that size of array, you really need to have the 900 amp hours to absorb that, so that you're not, in the middle of the night having to get up and run the generator.
Yeah, a lot of people ask to me about Mr. Lopez, can I create that configuration with regular batteries?
I wouldn't think, it would be a good idea, because if you use, there's a couple of things with the different battery technologies. So there's basically a few different ones. There's the wet cell technology, which is the old one where you add basically water to the top. In the past, those have been known to create hydrogen gases, which is extremely explosive. So you could have a spark and blow up your whole battery compartment. So those aren't really used all that much. What's replaced those in the marine industry is AGM. It's basically a glass liner between the different cells, which they're very good. I mean, I had mine, Lifeline, they were called. Excellent quality. They lasted 3 years. They probably would have lasted 5 years. Sorry, we were plugged in the marina. They would have lasted longer too. Nothing wrong with that. The only problem is when you're cruising out there, you don't have the ability to recharge that battery every single day to 100%. And that's what those batteries require. Also, what I noticed is the output curve. So with a lead acid, it degrades as the voltage declines. And you really notice that even like on the head pump, the toilet pump. You know, like in the mornings, all of a sudden the pump would make this weird noise because the voltage dropped significantly. That doesn't happen with lead. That curve is like pretty much straight across. It's always the same voltage all the way down to like, I don't know, 5% of the charge.
Yeah.
So it's always, which is very good.
Yeah. What type of battery do you have on the windlass in your boat?
So the windlass is actually connected to the house battery, which is very interesting because we had to replace the windlass actually after 14 years. It gave up the ghost, but I had a chance to speak with the manufacturer quick about exactly that question, because I said, oh, maybe, you know, it's basically a starter motor is what's in there. It's a huge motor, so it requires a lot of amperage, like up to 100 amps, to use that windlass. So he explained to me, he was a little bit, he wasn't very clear with it. He said the lithium battery using that, it's not really proven whether it's a problem or not. That's the way he put it. So he was not very committal on it. But for us, it's connected to the house battery. That's how the boat was wired originally. And with the new windlass that we put in a couple of months ago, it's working smooth as butter, no problems. And when I run that windlass, really, we only get, maybe I'm drawing, I don't know, 50 amps or even less than that when I'm bringing the anchor up. So I never get to 100 amps. Yeah.
Yeah. Oh, no. Nice, nice. Oh, Christian, thank you. Thank you very much. I am too happy with this conversation. You want to add some additional information to our followers about your experience?
Yeah. So, I mean, I think really after these 3 or 4 months, if I had to redesign that system, the only thing I would add to that is really I might put in a high output alternator, like from Balmar. They make a 200 amp hour with a different serpentine belt.
Great, yeah.
And then I would have another DC to DC converter to use that amperage from that alternator to power the house bank. So that's really what's missing from this setup. If I had to do it again, or I might even add that in the future, it's really not that hard to do. I think the most difficult part to that, the reason why I didn't do it, is not the cost of the alternator, but I would have had the cable run, which was like 6 feet from where the engine is to the battery bank. I would have had to use a very large cable, again, like, I don't know, 4-aught or something like that, big fat cable. And that's very expensive. And I would have had to drill some more holes into the bulkhead around the engine room. And I really didn't want to do any of that. So that's why I chose to basically not hook up those alternators to my house bank. So that's the only thing I would change on this.
Oh, great. I have another friend of mine, is Nicolas Mabru, the owner of the Mabru company. And he installed in a small boat, the Bertrand 28, with 2 inboard gasoline engines, 2 big alternators, those alternators of 100 amps. And it's too hard for the engines, keep the engines running in idle with the alternators producing power. It's a lot of load, no, on the engine.
Yeah, that was, I kept asking that question. I thought, wow, 200 amps. I mean, where does that energy come from, right? Yeah, the law of conservation of energy,
Yeah.
die. So there has to be a bigger load on the engine. You can't just run the engine at idle and expect to get 200 amps out of it. So I'm glad you mentioned that. That was actually another consideration I had. Why I didn't do that. I'm thinking, 29 horsepower diesel engine, 200 amps off an alternator. I don't know. I don't want to have a problem down the road. So I stuck with the 80 amp. The only thing I would do is maybe even take those 80 amp alternators and put another DC to DC in there, and be able to charge the house bank. But a lot of people say great things about those Balmar high output alternators. So I guess it's just a matter of experience, like everything else.
Yeah, that's true. Oh, no, thank you. Thank you, Christian. Thank you very much. What is the next step in your trip? Right now you are in Curacao and you start tomorrow?
Yeah, actually, we were here now in the marina for almost 2 months.
Uh-huh.
My mother was going to come down and visit, but because of all the prices of the flights and all this, she wasn't able to make it. But it was a very nice marina here. We made some really nice friends, saw a lot of the island. So actually, day after tomorrow, we're going to move the boat to an anchorage here. We're going to stay here for another, I don't know, 3 or 4 weeks in Curacao on Anchorage. And then we're going to sail off to Bonaire. We're going to be in Bonaire for a month. And then we're going to sail up to the Virgin Islands in November. And then
Uh-huh.
we're going to do the Spanish Virgins, the U.S. Virgins, the British Virgins. And then maybe around Christmas time or New Year's, sail down the Windward Islands all the way back down to Grenada. That's kind of the plan for this next.
Oh, great, great. I appreciate your time, Christian. Thank you very much. Say hello to your wife, and God bless you.
Thank you, Alvaro. I really appreciate the opportunity to discuss what I've learned over these last 3 months, and hope to see you again sometime soon, and keep up the great work with the classes. I can't thank you enough for what you've taught me in the past. I use it every single day, and it's really invaluable. I think your students have a tremendous opportunity with learning what you teach them, because it's needed. This type of knowledge is so desperately needed out there. And you're definitely a leader in giving that knowledge to the students. I appreciate that.
Thank you. Thank you very much. God bless you, and I hope see you soon.
Thank you. Bye.
Thank you.